You ever get that feeling of whiplash? One day the science says one thing, and the next it seems to say the complete opposite? It's frustrating, right? And it really wears down our trust. But what if the problem isn't that scientists are just wishy-washy? What if the real problem is that we are fundamentally breaking their findings every time we try to talk about them? Well, let's dig into a concept called epistemic translation and a new way to build trust. Not on some illusion of certainty, but on being transparent about uncertainty itself.
We've all seen a headline just like this one. It feels like a gotcha moment, doesn't it? Like, aha, the experts failed us again. It creates this whole narrative of betrayal. But framing it this way, this whole idea of scientists being wrong, well, it just completely misses the point of how science actually works.
So here's the big idea we're going to unpack. Science's greatest strength is that it's designed to be wrong in very structured, very informative ways. An update to a finding isn't a failure, it's a refinement. The real problem is that we actively destroy that vital structure, all the uncertainty, the confidence levels, the conditions for change, when we translate it for everybody else. And this is absolutely crucial. This isn't about finding a better slogan or a catchier soundbite. This is a system failure. Think of it like a really low-quality MP3 file. The original, rich, detailed scientific finding gets compressed as it moves from the lab to you. And all that nuance, all the critical context about uncertainty just gets lost forever. It's gone.
So here's how we're going to walk through this. First, we'll look at the certainty illusion. Then we'll start building the solution with an infrastructure for uncertainty and the rules for due process for knowledge. We'll stress test it by guarding the system, see the framework in action, and finally talk about what a new basis for trust really looks like.
All right, so first up, let's actually map out the pipeline where all this information destruction happens. It's a surprisingly predictable process that turns valuable provisional knowledge into something brittle and ultimately false. Okay, just look at this pipeline. It all starts in science where you have this really rich picture, right? A full range of possibilities, clear confidence levels, all the known limitations. But then it hits the policy world and that beautiful range just gets flattened into a single number because that's easier to make a decision on. Then the media grabs that number and turns it into a headline that just screams true or false. So by the time it gets to us, it's treated like a simple, unchanging fact. And then when the science naturally updates, it feels like a betrayal, not like a refinement. And here's the thing. This isn't an accident. Each of these domains is playing a totally different game, with a different goal, even a different definition of what truth is. For science, truth is a process of refinement, sometimes over decades. For politics, truth is something you can act on right now. For the media, truth is a simple, attention-grabbing event. And for us, the public, truth is often just simple rules of thumb that have worked for us in the past. These systems are just fundamentally misaligned.
And this misalignment leads to a really critical error. We confuse the is with the ought. Science can tell us the probability, let's call it P, of what's likely to happen, but what we ought to do about it, our values, or you, that's a totally separate political debate. Should we prioritize public health or the economy? When someone says, the science says we must do X, they're hiding a value judgment behind the authority of science. And that, my friends, is a recipe for disaster.
Okay, so if the problem is a broken system, the solution can't just be, hey, let's message this better. No way. We need new infrastructure. So let's look at a proposed toolkit that's actually designed to fix the system from the ground up.
The solution here isn't just one big idea, it's a full toolkit. Seriously, think of it like a carpenter's toolbox, filled with very specific things, from core principles to communication templates and checklists. And they're all designed for one purpose: to preserve clarity and build real, durable trust. At the very heart of this toolkit are 5 invariants. Think of these as absolutely non-negotiables. They are the essential pieces of information that must survive the translation process to avoid that catastrophic information loss. For example, you absolutely have to state the update triggers. What new information would change this finding? That way, when an update happens, it feels like a planned refinement, not a shocking failure.
So how do you make sure everyone actually follows these rules? Well, you create a standard, a kind of due process for knowledge claims. And that's exactly where the Epistemic Due Process Checklist, or EDPC, comes in.
And this analogy just illustrates the idea perfectly. Think about accounting standards, right? They don't tell a company what business decisions to make. They just force the company to disclose its financial risks in a standardized, auditable way. The EDPC does the exact same thing for scientific claims. This isn't about censorship. It is about mandatory, transparent disclosure of uncertainty. That's it.
And it has teeth. A claim actually gets graded. If it passes, fantastic. If it's conditional, you have to be totally upfront about what's missing. And if it fails, it cannot be amplified by an institution without getting a formal temporary waiver. This creates real, powerful incentives for getting it right from the start.
Now, a really crucial part of this due process is extending quality assurance beyond just the experts. In situations where the stakes are incredibly high, the communities that are actually going to be affected by a decision, they have to be part of the process. This is a huge move toward fairness, and it makes sure the knowledge being used is actually relevant and accountable to the people it impacts.
But their role is very, very specific. They don't get to second-guess the technical science. They can't just veto a finding. But what they can do is ask, hey, are the values being considered here fair? Or does this communication even make sense to us? Or are you applying a finding about a narrow group to our very different community? Their power is procedural. It's focused on fairness and clarity, not on technical arguments. Now, of course, any system built on rules can be gamed. So a truly robust framework has to anticipate these bad faith attacks and build in defenses from the very beginning. Uncertainty laundering, that's a classic. You scream with certainty in the headline, then you bury all the caveats and hedges down in paragraph 8. The defense, a mandatory check for headline body consistency. Simple. Or think about this common trick, applying a finding from one very specific group to everyone. For instance, saying a vaccine is 95% effective based on a trial of healthy 30-year-olds, and then letting people think that same number applies to immunocompromised 80-year-olds. The defense is just explicit disclosure. You must say who the finding applies to. Okay, I know this has all been a bit abstract, so let's make it super concrete. Let's see what this framework actually looks like in a real-world communication. Just look at the difference here. On the left, you've got the typical, vague press release. May spread more easily. That just gives you anxiety without any real information. Now look at the right. The compliant brief is a world of difference. It gives you a specific probability range. It labels the volatility as emerging. It clearly states what we don't know. It explains the rationale for our actions. And, this is the key, it tells you exactly what new data will cause an update. Suddenly, an update becomes an expected refinement, not a shocking reversal. What this all points to is a fundamental shift in where our trust should come from. It's not about trusting in the certainty of experts, because, let's be honest, that certainty is often just an illusion. And this is the core takeaway. This is the legitimacy theorem. Trust and legitimacy in a complex world doesn't come from pretending you have all the answers. It comes from having a transparent, auditable, and fair process for navigating the answers you don't have. You learn to trust the procedure, not just the pronouncement. So, where do we start? Well, this isn't an all-or-nothing system. There's a minimum viable kit we can use. It starts with the 5 invariants to preserve the core info. It uses that simple 4-line brief template and adds one crucial sentence to set expectations. It's all backed by the EDPC checklist for compliance and a confidence trail for auditing. This is the toolkit. This is how we start building a more resilient, more honest, and ultimately more trustworthy relationship between science and society. The only real question is, are we ready to start building it?